Hi everyone, welcome to Grade Up. In our previous lecture we have seen sets, relations, function and lattice. In our today's lecture we will be seeing types of lattice. Before that, what is lattice? So for a poset, if for every element we have GLB and LUB, then it is called a lattice. And now we will be seeing types of lattices. Okay, so let's start. Sublattice. What is sublattice? So any subset of L, any subset M of L, okay, then if you have a subset M, it should be lattice. It should be first of all lattice. That means that for every pair you must have LUB and GLUB, and the second condition is that for every pair of element A comma B belong to my M, A comma B belong to my L, LUB and GLB are same in M and L. So whatever the LUB in L, that should be the same LUB and GLB in M also. Okay, so you must remember that because that is really important. See this example. This is a lattice. If you have any doubt, try to find for every pair of element LUB and GLUB, and this is a lattice. Now I take two subset of this lattice. This is the one subset, okay, and this is the second subset. Now you need to identify which of them is a sublattice of lattice this. So these are the definition written here. Try it yourself, okay, and I will do it. First we will see the second example. Here, okay, A, E, Y, X. So here A, E, X, Y, okay, and A, E are not related to each other. A and E are not related to each other. There is no way that they are related. Similarly in this, A and E are not related to each other. Now we will try to find LUB and GLUB for AE. What is that? If you see the LUB, then it will be Y. So remember, what is LUB? LUB is least upper bound. We studied that thing in our previous lecture, okay? So that is least upper bound. And what is GLB? It is greatest lower bound. Greatest lower bound. Lower bound. So we have seen all these things in our previous lecture. Now I am asking you to find the what is the here. First of all, you need to find what is the LUB and GLUB of A and E. And if you see that it is Y and X, and I am asking you here, then also it is Y and X, okay. So the first condition was that it should be the subset, M should be the lattice. Yes, because it is lattice, because for every pair of element you have LUB and GLUB. So first condition is satisfied. And what about the second condition? That if whatever the GLUB and LUB here for every element, it should also be here. We have checked for A and E, that is correct. And if you try for A and Y, it will be same, because A will be the least upper bound, greatest lower bound, and it will be the least upper bound. So if you try it, it will be same. So this is the sublattice of this lattice. But I am asking you, try for this. Try for this. You will see an interesting thing. Okay. Now we will see. Try to find the GLUB and LUB for A and B. If I try here, then here what is the LUB? LUB will be C and GLB will be X. Okay, LUB will be C and GLB will be X. But if you try here, LUB will be Y, but here it is C. And our second statement is saying that LUB and GLB are same in M and L. So it should be same in M and L, but it is not happening here, because here it is C and here it is Y. So this is not the sublattice of this lattice. Okay, so you need to verify yourself. You need to solve it like I do it. Try for every pair of element. You just need to check for those pair of element where there is a chance of that it does not follow. What if I check for A and Y? Obviously A will be the greatest lower bound and it will be the least upper bound. Why? So there is no point of checking that. You need to check for those pair where we have a chance that it may violate the property. Okay. Now what is bounded lattice? So in bounded lattice, you will be having an element X such that everyone is related to that. So that is what is written here. Let L be a lattice with respect to R. Okay, so R will be the relation. If there exists an element X belong to L such that for all A belong to L, A is related to X. Suppose we having 5 element more, so it is related, it is related, it is related, and it is related, and then this is gonna be the X. So I take an example, our previous example, this was our lattice in our previous example. So what is the upper bound? What is the upper bound of this lattice L? So you see that it was A, it was B, and it was X, and this is Y. Okay, so now what is the upper bound? If you see that A is related to X, B is related to X, and also Y is related to X, you will say how it is relative. I told you in our starting lecture that we don't need to see the count in hash diagram, we don't need to draw the transitive edges. So Y is related to X through the transitive edges, but we don't need to draw them in the hash diagram. So every element is related to X, then X will be the upper bound, and this upper bound of lattice L. If I ask you what will be the lower bound in this lattice, it is just the opposite. How? Every element, it is like that. If there exists an element Y belong to L such that Y is related to A, so this element should be related to every other element Y. How it is relating? Let's see. Y is related to A. Okay, directly seen from the hash diagram. Y is related to B. Yes, it is directly also seen. Y is related to X. I told you how it is related. So yes, Y is related to every other element. Then Y will become lower bound. And when every element relate to X, then X will become upper bound. So you need to understand these two terms. When you have upper bound and lower bound in a lattice, then it is called bounded lattice. When you have both of these, upper bound as well as lower bound, then it will become bounded lattice. Okay, now I am giving you an example of lattice which is not bounded lattice. You can also think of, there are many examples, and I am giving one. This. So it is the set of n natural number. Okay, natural number, and our relation is less than or equal to. So it is 1, 2, 3, 4, so on. So here what is, we don't have an upper bound. We don't have any upper bound because there are lots of many number are there. Whenever you say that 100 is an upper bound, I will say that 101 is should be the upper bound. If you say that 1000 is upper bound, then I will say 2000 will be the upper bound. So it is, there is no upper bound, but yes, there is a lower bound which is 1, but it is not a bounded lattice because we will be not having upper bound. Now complement of a lattice. So all these are the type of lattices and question are framed based on that. So you need to understand the definition well. Once you understand the definition well, I don't think that will be much tough. So understand them. Okay. Complement of an lattice. Let L be a bounded lattice. So what is a complement? I told you this is the lattice and we need to try to find the complement, and we are trying to find the complement of an element, for example like 2. So for that 2, what we need to do it, we need to find another element such that their LUB will be X. And what is X? Upper bound. Upper bound of whole lattice. Here, like when every element is mapped to that, so that X is used here, that X is used here. Okay, that X is used here. So that will be upper bound. Okay, and now GLB will be is equal to Y. GLB will be is equal to Y. So we need to see these two things. Okay, so I have animal 2. Now try which of them do you think that an element such that their LUB will be 30, and because 30 is the upper bound, I can clearly see that 30 is the upper bound and 1 is the lower bound. And now I wanted to find another element for 2 such that their LUB will be 30 and GLB will be 1. Okay, so if you see that here 2 is there, if I pick 3, then yes, LUB will be 30 and GLB will be 1. So I can say that 3 is the complement of 2. Can there be more complement for an element? Yes, there can be more element, more complement. For example, for this 2, if you see the 3 or if you see the 5, it is also the complement of 2. So for 2 we got 2 complement which are 3 and 5. Similarly, if you see for 3 there are 2 complement which are 2 and 5. For 5 also there are 2 complement which are 3 and 5. Try it with yourself and okay. And this definition also saying the same thing. Okay, this is the symbol for LUB and this is the symbol for GLB. Okay, just the notation, sometimes they use it, so remember them. Okay, so that is what it is written in the definition I told you in this example. Now what is complemented lattice? We have seen the complement of an element. Now we will need to find the complemented lattice. Complemented lattice is also when every element having a complement in a lattice, then it is called the complemented lattice. You will be saying that can an element does not have a complement? Yes, there are many ways we can show that an element does not have a complement. But in our this, here we will be having every element have complement. So this is also a complemented lattice. Now we will see this example and try to say whether it is a complemented lattice or not. So first of all, try to take only those pair which you are having doubt. So actually this example is easy. Here we need to find complement for every element. Complement for every element. I will start with 1. What is the complement for 1? I asked you. That will be 18 because their LUB must be equal to upper bound. LUB must be equal to upper bound. And what is upper bound? Upper bound here it is 18. So LUB will be 18 when I pick it and GLB will be 1. Okay, so for 1 I am writing is complement here, 18 is the complement. Now for 2, try to find yourself which is the complement of 2. So if you see the complement of 2 will be C9. What will be the LUB? 18. Okay, upper bound is the LUB. And what is the GLB? That is 1, lower bound. Okay, so yes, 9 is the complement for 2. Similarly, you don't need to find for 9 also because these operations are commutative. Okay, so for 9 our 2 will be the complement. Now we need to see for 3 and 6. And also for 18 the complement will be 1. Now for 3, what is the complement? So we will try to find an element such that their LUB will be upper bound and GLB will be lower bound. So try it. I will say let's see 6. If you take 6, then the LUB will be 6 and GLB will be 3. So that is not correct. If you take 9, then also for 3 I am taking. For 3 then LUB will be 9 and GLB will be 3. If I take it 2, so I take it 2, then LUB will be 6 and GLB will be 1, and 6 is not the upper bound of the lattice. So yes, 2 is not the complement. So 3 does not have any complement. 3 does not have any complement. Similarly here 6, it is also true, it does not have any complement. So this lattice is not a complemented lattice. I am writing here not a complemented lattice. Complemented lattice. Why we are reading this you will understand because when you saw the questions. Now what is distributive lattice? So you must know the distributed law. We have studied in our Boolean algebra in our 12th. Many times we have studied. It is also similar here, but here the operation are GLU and this is LUB, least upper bound, and this will be greatest lower bound. So these are the operations. So we will see that this, and you can see that it is simply the distributive law we have seen. But the problem is that every lattice does not follow this rule. Every lattice does not follow this rule. Every lattice does not follow this rule. And we are interested to find which of them are following. We are interested to find which of them are following and also in those which are not following. So how we can say that? So this is an interesting thing. in a distributed lattice, complement of an element if exist is unique. What is? It's unique. So in distributed lattice, if you find an element for which you will be seeing two complement or more, then you can say that it is not a distributed lattice. That is simple. Each element has at most one complement, at most one complement. So, and each element can have one complement or zero complement. But if an element having two or more complement, you can directly say that it is not distributive lattice. Now we are seeing two examples that are not distributive lattice. So this one and this one. This one is known as pentagonal lattice. It is just the name sometimes used, and this is the kite shape lattice because it is kite shape and this is pentagonal. Now I try why it is not distributed. I told you, if for an element if we will be having two or more complement, then we can say that it is not a distributed lattice. So try to find any such element. So in this I marked A. Okay, now I will try to find the complement of it. So complement for it, I pick C. So yes, their LUB will be Y, which is the upper bound, and GLB will be the X, which is the lower bound. Okay, that is fine. So C is the complement. When I try to find another complement for A, no, there is no other complement because you pick B, then what LUB will be B and GLB will be A. So that is not correct. Now if you try with B, the same result you will get. But if you see the C, this C, it is having two complement, and you can easily see that A and B are those elements which are complement of C, So these two are the complements. So I can say that it is not a distributive lattice, because in distributive lattice any element cannot have two or more complement, and here C is having two complement, so it is violating that property. That is why it is not a distributive lattice. Similarly, if you see here in this kite shape lattice, A is having two complement which are B and C, B is having two complement which are A and C, and C is having two complement which are A and B. So this is also not a distributed lattice. In distributed lattice, an element can have at most one complement. Either it will not having any complement, that is also fine, but when it is having a complement, it should be one. If it is having two complement, then we can say that it is not a distributed lattice. So these are the two things that we always try to do it to prove that when a lattice is not a distributed lattice. First thing is find pentagonal and kite lattices as a sublattice. Okay. Second thing is, in order to prove that lattice is not distributed, either find an element for which there are more than one complement. When you find an element for which you will be having more than one complement, you can directly say that it is not a distributive lattice. So try to do that, or try to see whether there is a pentagonal shape lattice as a sublattice in a lattice, or a kite shape. So seeing these two things is easy. So I always prefer them, and I always try to say that. Okay, I asked you a question. So we have seen this relation. Is it gonna be distributive lattice? So if you draw the hash diagram of it, then it will be like that. How can this kind of structure is present in this? It is so. Obviously this kind of structure cannot present in this, so it is a distributive lattice. If this kind of there are chances that this kind of structure are present in this lattice, then we can say that it is not a distributive lattice. Boolean algebra. So what is Boolean algebra? If lattice L is called Boolean algebra if it is distributed and complemented. So it should be complemented. What complemented says? Complemented says that for every element you must have a complement. Okay. So complemented is saying that for every element you must have a complement. And what distributive saying that for any element there will not be two or more complement. Okay. So for any element there will not be two or more complement, and this is saying that there should be complement for each element. So it means that every element should have unique complement. So that is the meaning of this statement. Every element should have complement and also having only one complement. Every element should have one complement. Okay, in previous this we see this example. I asked you, can this be a distributive lattice? You see that 3 and 6 does not have complement. Can this be a distributive lattice? Yes, it may be. Why? Because there are no two elements that are having two complement or more. It can be a distributive lattice. Okay, now we need to find what is Boolean algebra. So we need to check whether it is or not. So for that, first we will see that for every element how many complements are there. For x the complement will be y, for y it is x, and for a it will be b, and for b it will be a. So it is a Boolean algebra because we have a unique complement. Okay. In a lattice defined by the hash diagram, given we need to find the complements of e element. How many complements are there? So I told you everything. Try to find it. Okay. First of all, what is upper bound? A is the upper bound. What is lower bound? F is the lower bound. So A is the upper bound, and this is the lower bound. Okay, lower bound. Now try to find the complement of element E. If I say B, B cannot be, because then B is not. Okay, if I say G, okay, so yes, let's see. So water is flowing from here and it is meeting here. So yes, A is the upper bound and then downward, then yes, F is the lower bound. So G is the one complement. What if I told you C? If you go, water is flowing here, it reach here, and water is here, reach here, and for downward it is going to be like that. Yes, C is also the complement, and for D, D is also the complement because water is flowing upward and it is downward. So how many complement for E element? G, C and D. Okay, so we will be having 3 complement. That is the answer for this question. So guys, these are the basic definition. You need to understand the definition properly, then try to solve some problem on this. That is fine. Okay, so do practice. Thank you.